It's not every day that you get to walk on stage and there's Dirty Dancing playing in the background, but then you have to explain this right after that. So, all right. Okay, so I'm Rosemary Wang, and today I'm going to talk about fitness function-driven development for operability. Now, there's a whole lot of words on this screen, and it's a whole lot of theory, and I actually didn't really believe in it that much. But I'm going to start with a little bit of story, go into some of the theories, and then I'm actually going to do a bit of coding, which loose coding. Okay, so there will be some code. If you're interested, if you have a very difficult time discerning contrast on the screen or font size as I'm doing this coding, I have a VS Code live share available. So you can go to hashi.co/2019-Monitorama, and that will add you to my collaboration session on VS Code. So you'll be able to see what's going on. And if you're on the live stream, you'll also be able to see it better than the camera is probably projecting it. So just to make sure that people can actually see it. Cool, I'll leave that for a second so people can get on if they need to. hashi.co/2019-Monitorama. Okay. So how this story started. I was a consultant for ThoughtWorks, and I came from what you would call, I guess, an operations background, right? I was the person plugging in network switches and then configuring BGP and doing all sorts of weird things. And when I joined ThoughtWorks, it was a lot of, basically a lot of thinking involved, as you can imagine, but also a lot of software development practices that I wasn't fully aware of. And something that we would do project after project was we'd go to the project, we'd basically be tasked with functional or performance-related improvements, right? And so this could be our website went down Black Friday, we need to make sure it's going back up again, et cetera. And the idea was that any functional or performance-related improvements should map to happier users. Pretty great story. And then you'd make some architectural changes to basically make those functional and performance-related improvements to make even happier users. And you'd keep going in this cycle. And this cycle is the concept behind evolutionary architecture. There's a book I'll cite later on, but the term basically means you evolve your architecture so that you have happier users, right? And you get better business value. It's not necessarily that your architecture stays static over time. So this makes a lot of sense. Some things you have to change. But the problem was that whenever I would have to operate systems or to have to sit and work with people who operated systems, the architectural changes affected everybody. It wasn't as if we made functional and performance-related improvements and we could say, oh, it's great, development, awesome, we're great, we pushed code to production. The problem was that everybody else had to actually do something for it, right? So security, compliance, operations, I say that because the definition can vary widely. Development, infrastructure, platform, which again can vary widely, and finance. All of these stakeholders actually had to do something, in part with the operations. And why does that matter, right? Well, here's the issue. Any architectural change you make, any decisioning you make, does have an operational impact, whether you want to admit it or not. So container architecture. If you move to containers, you have to figure out a different way of managing vulnerabilities, of addressing and patching vulnerabilities. If you're doing microservices, you have to do something better, right, with the way you're understanding your unknowns. You have to do something differently. GDPR was a big one, right, a couple of years ago. When you did GDPR, you had to figure out how your data inventory was going to be reported. Who was handling that? How was it going to be handled? How would you evaluate and assess whether or not you are truly GDPR compliant? And continuous delivery. We've already heard this today. But continuous delivery and change advisory boards, the number of times I've had to explain change advisory boards in the context of continuous delivery was really complicated because infrastructure changes would have to go through this change advisory board process, right, of people reviewing these route changes. And it wasn't necessarily the case that they knew what those route changes would mean. They didn't necessarily know what those infrastructure changes would impact. So continuous delivery and change advisory boards, did that actually work? And does that actually kind of meld together? Now, you can debate all you want about it, but this is basically what happened. I saw this enough times, and I realized that our ability to keep a system secure and in reliable functioning condition really was compromised by these architecture changes. We weren't really considering the other half. So we heard a lot today about happier users. We heard a lot today about SLOs. But this is the other side of the coin, right? Like, how do you think about keeping a system secure and reliable, and how do you understand that? How do you measure that? Well, there's not really a measure, but there's something kind of close. So in the context of evolutionary architecture, by the way, the book is by Neil Ford, Rebecca Parsons, and Patrick Kwa. But they present this idea of a fitness function, and it was actually borrowed from genetic algorithms. The idea was that genetic algorithms needed to kind of fit to a sequence, right? So how good was the genetic algorithm when it fits to a sequence? It would be a series of number of ones, for example, that says, yes, it fits, or no, it doesn't really fit. And some genetic algorithms were better fits than others. So a fitness function in the system space is a particular type of objective function that is used to summarize how close a given design solution is to achieving the set aims. Sounds really abstract, right? Well, it can mean a lot of different things. Service level objectives can be fitness functions in the system space. Nothing says that they can't be a service level objective saying that you have to be, 20% of requests must be within X number. You can make a decision there. But that is a fitness function that's saying how close am I to achieving my aim of resiliency. But there are more complicated kinds of fitness functions to make your operability a little better. How you secure and maintain your system in reliable condition might be more nuanced than just saying it's a service level objective. So how do you even understand this? What do you mean by more nuanced, Rosemary? Well, here we go. This is a Jez Humble quote that I borrowed, and then I added something else too. So the quote goes something along the lines of testing are your known knowns, monitoring are your known unknowns, and observability are your unknown unknowns. And then I posit that fitness functions are often the things that stuff someone else knows. So those are the unknown knowns. So those are things that maybe someone else in your organization knows about, but you have no awareness of. And this is actually pretty common. As an infrastructure engineer, sometimes I would have no clue what security was expecting, right? I didn't necessarily have security expertise, so I had to go find someone with security expertise to help me understand what was going on. So how do we move the unknown knowns into one of these three instead? Maybe not observability, but at least into monitoring and testing. All right, so this is where fitness function-driven development comes in. All right, we're almost there. We're almost at the coding part. So basically, fitness function-driven development introduces continuous feedback for architectural conformance and informs the development process as it happens rather than after the fact. It borrows a lot from test-driven development. The idea is, what if we thought about this earlier? So a collaborator of mine, Paul and myself, we're like, let's actually try this, right? We heard a lot about these theories. We talked a lot about it. We would sit there and we'd brainstorm about it. But actually, let's try it on a project and see what happens when we think about how do we develop for architecture conformance at the beginning rather than at the end, right? Maybe we'll actually address some technical debt earlier. We won't have that technical debt. Maybe there are some unintended consequences that we don't even realize. So let's actually give this a try. So what I'm going to do is actually live walk through kind of a short example of what happened. Now, we had a lot of fitness functions, a lot of them. There was a whole article that the link is attached at the end. But the idea was that we had a lot of fitness functions, but one space that I really enjoyed was security, because security has a lot of tools. There are a lot of tools to understand what's going on in systems, how to understand if there are vulnerabilities, how to understand if there are problems in the system or no problems at all. So let's actually try this. So I'm going to go to my live coding session. So for those who are not able to see this, everybody size-wise, is this okay? Just making sure. Bigger? Okay, let's do that. This is the problem with live coding. Okay, all right, that'll work. Okay, so let's start with tests, right? So fitness function-driven development. If we base this off TDD, our test will run red first. They should fail. And then we'll make them green. Simple. So a fitness function which assesses our architectural conformance, we should not be conformant at all. We shouldn't even be close. So let's actually make it conformant. So I'm just going to run, oh, there we go. So I'm just going to run go test, which that's all it's going to do. All right, so you'll notice that there are some failures here, right? Oof. No one likes these little run pass fails. All right, so you'll notice that we're SOX compliant, yay. So according to compliance, we're SOX compliant. So for those who are not aware of SOX, it's Sarbanes-Oxley, so you have to have 2 approvers before you go to production. Cool, right? We're not gonna talk about how that goes in the continuous delivery space, but let's say we're SOX compliant from compliance. But here's the problem. I see a fail in the development pipeline deployment time, right? So my development teams expect it to be less than 10 minutes. They've picked some kind of number, right? So what we did was we interviewed the development team and said, hey, what do you actually expect? And they said, well, we want it 10 minutes. Again, we could go through that, but we were like, okay, let's go back to the drawing board. So when we actually looked at the deployment time, we're like, wait a second. It's 12 minutes. Why is it 12 minutes? It's 2 minutes over. Now, this doesn't seem to make any difference, right? But our first mistake was we did this in raw numbers. We probably should have done it with some percentage, right, within a certain bound. That was the first thing. The second thing that we actually learned in this process was that there was an extra 2 minutes tacked on to this development pipeline because of something down here, which was the security application dependency vulnerability scanning. So dependency vulnerability scanning and container vulnerabilities actually added 2 extra minutes to the pipeline. And so this sounds like, oh, who cares, right? But here's the thing. No one knew this. No one knew that vulnerability management was being added to the pipeline until we wrote a fitness function to actually assess this. So we started to develop a shared learning context, right? Understanding that, hey, here we are, we're trying to understand what's going on and how we're going to operate our systems, and the expectation is everybody needs to have some scanning. All right, so let's go back and let's figure out what's going on. So the first thing I'm going to do is I'm going to actually do this. I'm going to change it to 10 because it's very, very primitive, but also I don't have time. So development test. As you can see here, all of this is mocked because I don't want to trust conference Wi-Fi. So a lot of this is mocked, but the idea is that we'd wrap these functions and say, hey, we'd go through and we'd say there is some kind of API that we call to grab this information. All right, so what I'm going to do is I'm just going to say, for now, all right, I'm going to get deployment time. It should be under 10 minutes, and that should be that. So I'm going to put it under 13 minutes, but really it should be some kind of percentage, right? So we were able to go through and actually do that in the real fitness function. But for now, let's just get it passing. But the other interesting thing that we actually figured out was that when we dove further into kind of the security vulnerability space, not only was it adding extra steps to the pipeline, we also discovered that from an operational standpoint, the security team expected every vulnerability to be addressed. Now, this isn't practical because sometimes when you scan things, 500 vulnerabilities would pop up. So when we added these fitness functions to assess the vulnerability reports, there would be 600, 700 vulnerabilities. And no one can actually sit and remediate all of them, right? So how do you understand what's important and what's not? As you can see in this vulnerability report, we have a medium severity. We also have a critical severity. And so we asked the security team, is it really practical from an operability standpoint that every single vulnerability has to be remediated? And their answer is not really. It's going to depend on the attack vector. It's going to be depending on the severity. So we had to say, okay, this isn't practical. Let's actually make it a little bit more specific to say, it's got to be medium or higher, right? Or it's got to be high or higher. So if it's critical or high, then it's important for us to do. So what we're going to do, or what we ended up doing, was we actually ended up writing some logic in code. Now we can talk about how interesting this could be. But we were able to express this want, this architectural conformance through code, right? And yes, there's a case for everything where you shouldn't always use code to facilitate a human factor, but this really helped all of the teams understand a shared logic, right? They were able to see this as a test and say, oh, this is an architecture that I need to understand, or this is a part of the operability for the security team that I need to understand. So if it's medium, I'm just going to ignore it, and really all I should get is maybe like 1 vulnerability in this test, right? So it's critical. Now, imagine these are in pipelines. I apologize. Again, the mocking is a little confusing, but the idea is that I only want to focus on critical vulnerabilities, and actually we continue to add to this logic to say, okay, besides the medium case, we also want to understand attack vectors. So if it's a network attack vector and it's not valid in the certain situation, we can actually add some logic to it, or we can find a tool or call out to another API to understand that. So the idea is we're building in these resources so even developers can go into these tests and understand what logic is expected. So as you can see here, there's a couple of things, but we're going to run this again. And one of them may or may not pass. So we still have a critical vulnerability over here, so we have to remediate that. So in the pipelines that would run, we have these improved logic that says, okay, here's a critical vulnerability. Let's actually flag it, and then the development team was aware, and it wouldn't go to production. So from an architecture standpoint, they said, hey, we deem that anything with critical vulnerabilities can't go to production. Stop it. It doesn't go to production. And then maybe things would be whitelisted, but that was a conversation, and it was a conversation starter between teams. So then we went to kind of like the next bit, which was really interesting. So we actually didn't know this, but we had two kind of fitness functions written similarly. The first one was for the compliance team, which, as you have noticed up here, passed. However, there's a second lovely test down here that said, SOX review with product owner and team lead. What we didn't realize was that when we had separately reviewed with the security teams and compliance teams, that both of them had different SOX reviewer expectations. The compliance team, so I'm going to pull up their code here. The compliance team said, oh, we're okay as long as there are two different approvers before it goes to production. However, from a security standpoint, they had interpreted it a different way because they didn't actually standardize across any application on understanding what the SOX compliance was. By the way, the compliance team really struggled to understand how to pull the information about SOX compliance because it was mostly just going through each pipeline or each individual application and seeing who was approving it, right? So there really wasn't an automated way to do this. So from an operations standpoint, if they were audited, they had to go through and take the time to look for who was approving it and who wasn't. So whenever we actually looked at the security SOX reviewer criteria, we noticed it was actually far more constrained. The approvers had to be a team lead or a product owner. Now this has a lot of side effects from an operability standpoint, right? Because now it means you have another step, you have to go to someone, you have to find them, you have to say, hey, can you sign off on this before it goes to production? And that messes with your continuous delivery architecture. So what we had to do is we brought both compliance and security teams and said, okay, like, can we come to an agreement on what we really want out of this? And eventually the consensus was we would rather have the constrained approver mechanism with the idea that it does accumulate a bit of tech debt, right? Because if you're saying we do want to deploy in 10 minutes to production, well, now you have to find a team lead and product owner within the 10 minutes. So it was an interesting trade-off to discuss and understand. So here we are, approver, team lead, product owner. And if we did actually fix this, change this, the idea is that we would actually make this consistent with the compliance fitness function. Or we just make one fitness function and tag it as SOX to say this is specifically to do with SOX compliance. All right, so the next one, security alerts. So this was actually a really interesting one. And we talked a lot about alerts today already. And we talked a lot about how do you know whether or not the alert is really useful to you or not, how do you actually understand and go back and tidy up, right? So how do you remove that tech debt of having alerts that you don't need? Well, this is really interesting. The team one day was telling me that they ran out of mailbox space, their email inbox space. And I was like, what do you mean you ran out of email inbox space? They said, well, we get a lot of alerts. And I was like, why are you getting alerts by email? That was my first question. But the second question I said, how many alerts are you getting by email and how many of them are you actually addressing? And the answer was, we're not actually sure. So we wrote, of course, a fitness function. And I told them, pick an arbitrary number of like the things that you want to address in a day. Okay, like what do you really want to address? And they said, all right, it'd be nice if we addressed 75% of what we deem as critical alerts in the day. All right, 3/4. Okay, let's just see what happens. When we did this exercise and we wrote the fitness function, we called back to kind of like their register logging, the registration system that they use to determine if they acknowledged it or not. We found out they only acknowledged actually 25% of the alerts. So basically they were getting full email inboxes and only acknowledging 25% of alerts. So we went back and we actually said, let's take a look at what you're actually alerting on and why you're thinking that you need to address the alerts or not address the alerts. And so this is a very small subset of the alerts they were getting from the Security Information Events Monitoring System. Some things were like unauthorized process. Other things were like root login. Other things were like user not authorized. Other things were like open security group. But really, the only ones that they actually acknowledged once we categorized, restructured, did some manipulation on the data was actually root login. So they only ever responded to root login, which I was like, that's great, except what happens to all the other ones? And they said, well, I guess we just don't respond to them. So what we ended up doing was we ended up cleaning it up a bit, right? We said, let's go back and actually take the SIEM and reevaluate SIEM, meaning the Security Information Events and Monitoring System. Let's actually go back and restructure the way it's funneling the alerts so you're only picking up the things that you need. And this is a bit of a cheat, but I'm just going to delete all the other alerts that you need, and we'll work on how many of the other ones you truly actually need to alert on, right? And so the idea was that they would get to the 75% within a day. They weren't completely 100%. There were a lot of things that we also had to clean up. But at least the alerts that they deemed as truly important were acknowledged. So this exercise kind of compelled all of us to go back and clean up our alerts. All right, so I'm going to actually skip this privilege escalation exploits. This shows a little bit of Falco, sysdig Falco, and the rules. But basically, they were like, we need to make sure there's no privilege escalation exploits. It wasn't just privilege escalation, sorry. This was just a recent CVE that was found in Linux. But for now, basically, they wanted to make sure that rule was in place. So this was an example of how you would assess whether or not those types of categories and rules were in place. All right, so the next and last one that I'll go through today is incident response plan, right? And no one really thinks about operability or like how you secure and make a system reliable, as runbooks anymore. But some teams do exist in that model. And in the security team, there was actually a security incident in the time that we were actually implementing functionality to production, which was pretty scary. The only problem was no one knew how to respond to it. So we didn't know who to go to on the security team to escalate this, which is bad, right? And the security team similarly said, well, we don't really follow this response plan anymore. It's 2 years outdated. So the last review was 2017. And we're like, okay, this can't be right. On top of that, no one actually had the correct link to the incident response plan. So what did we end up doing? Well, we said, let's see if we could write a fitness function that just goes out and checks if the incident response plan is available and whether or not someone's reviewed it, right, within a certain amount of time. From an operability standpoint, at least we can say, hey, it's been reviewed, we understand where it is. A developer who doesn't know any better, someone completely new, would be able to go to this test and say, okay, I see where the link is, I see it on the wiki. And so the idea was that once after it was reviewed, which I'm going to go here and pretend to review it, and change it to 2019 because we're going to get this test passed. The idea was that eventually we'd get these fitness functions to pass, right? So we'd actually be able to say, hey, these things are some of the ways that we express architecture conformance and architecture within our organization. So that's just a quick, very small example of what fitness function-driven development looks like in reality. All right, so let's kind of recap what happened, right? The idea was that we took the stuff someone else knows and we put it into the known unknowns or the known knowns. And why I say it this way is that the idea is some of this looks like testing. I just did TDD, it seems like, right? But there's also some of it that you might need to kind of bundle into monitoring too. Do you have gaps in where your monitoring might be, how you might operate if you didn't have those monitoring systems? So that's a question that you sort of answer as part of the different teams that you might have. So taking the stuff someone else knows and moving them to monitoring and testing is kind of what a fitness function, at least fitness function-driven development, will help assess. So everybody starts to know most of these things. In retrospect, when we sat down with the team and the project, by the way, it did go to production. It is running in production today after this exercise. What we did really liked about it was that at the time, KonMari, which is the tidying up thing, which is like, does it bring you joy sort of thing, was really popular. And so what the engineers joked was like, it was a bit like the KonMari method for their former assumptions, tools, and telemetry, right? The things that they thought they needed, it turns out they didn't need at all. And the things that they didn't know they needed, fitness functions were able to highlight that from an operations standpoint. So a great example of this is that we didn't talk about a development persona or an infrastructure engineer persona, but an infrastructure engineer who needed to know what service was running on what server or what container was running on the server. They actually didn't have any tooling to help them do that. So it highlighted the gaps in that process. It also opened a lot of discussions for technical debt. So to say, I'm going to make this compromise, right, and maybe we won't be SOX compliant, we should be, versus putting together vulnerability management, we have to make those assessments and we have to understand what kind of effort we make, right? So we have to say, do we assume this tech debt for now or do we go back to it later? So these fitness functions really helped kind of organize what kind of technical debt we were willing to accrue and at least enumerate the trade-offs from an architecture standpoint. And it developed a mutual learning context, which is really cool. Everybody started to understand, okay, here's how security works. And I actually learned a lot of security from it just by interviewing the security team and building these fitness functions. But even finance was actually really intriguing. I learned about chargeback, right? And every quarter there was chargeback for their on-prem, and now they have to do a monthly billing in a public cloud provider. So it actually helped me as a developer and infrastructure engineer learn about all these things as well. What I would probably improve if I were to ever do this again is trying not to over-optimize, right? We would get really hung up on some of these metrics, and the idea was that we didn't actually know what those metrics meant, right? And so it wasn't necessarily to say, you know, X% was right. It was just to say, can we even understand that X% is something we can measure? Oftentimes, we couldn't even measure that. And then it became a question of how do we balance the implementation of these fitness functions with review from stakeholders? Can we actually do that? You know, how do we actually justify that we're implementing this fitness function and taking time to do it? So over time, I think we got better at it, and actually it was really cool to see. And if you're curious to learn more, well, I guess the question is, can you answer this question in your architecture? What changed in our architecture that affects how effectively we operate, right? Can we actually answer that question? And in this case, I think we were able to. In other cases, maybe not. So give it a try, let me know. If you're curious to learn more, here are a list of references as well as this repository. There's actually the blog post and the book link associated here as well. And if you're curious to learn more, feel free to reach out. Thank you. Oh, he's up there.
Any questions?
This one? References? Okay. Okay, people can take a picture of the references. No problem. Slides are also on there too, so. Okay. Okay. Thank you.